Happy morning, student. In the present chapter, you will learn the behavior of bar magnet when it is kept in two mutually perpendicular magnetic fields. You will also learn the types of magnetic materials such as diamagnetic, paramagnetic and ferromagnetic materials. And at the end of the chapter, you will learn the application of magnetic material such as permanent magnet, electromagnet and magnetic shielding. Therefore, let us start the new chapter, magnetic materials. And what is the magnetism? Of course, this magnetism is caused by the motion of electric charge. You know that the building blocks of the material is atom. Atom consists of the electrons and electron carry the charge. Okay, already you are familiar with the basic properties of the bar magnet. Let us see this again. If this is the bar magnet, suppose this is the south pole and this is the north pole. Okay. First property of bar magnet is when the bar magnet is suspended freely, then it aligns in the direction of north-south. Okay. Therefore, it rests along the north-south direction. When you forcefully bring this bar magnet in the direction of east-west and leave it free, then what happens? This bar magnet will rotate along the axis of rotation. This bar magnet rotates along the axis of rotation. Okay, and therefore some torque is acting on the bar magnet. Okay, just in magnetic field due to the electric current. In this chapter, we have obtained the equation of torque acting on a current loop. Okay, torque tau is equal to the mb sin theta. Therefore, first property is when the bar magnet is suspended freely, it aligns in the direction of north-south. Okay. Second property of bar magnet is when this bar magnet is kept in iron fillings, then what happens? At the two ends of this bar magnet, iron fillings are attracted only. Okay. Suppose this is the 2 point. की ज्या 2 पॉइंट्सलाच आयरन फिलिंग्स फक्त काय होणार आहे? अट्रॅक्ट होणार आहे. That 2 points is called as a poles, south pole as well as the north pole. Therefore, bar magnet is called as a magnetic dipole because it consists of 2 poles, 2 equal and opposite poles separated by some finite distance which is nothing but a twice L. These 2 poles are called as the fictitious poles, which we can't distinguish which is the south pole and which is the north pole. Because if we cut this bar magnet into the 2 pieces, suppose this is the 1 piece and this is the second piece. Each piece has a 2 poles, south poles as well as north pole. Again you cut into 2 pieces, each piece has a two poles, south pole and the north pole. Therefore, magnetic monopoles doesn't exist. It always exists in the pair, couple च्या फॉर्म मध्ये बार मॅग्नेट काय होत असतो, एक्झिस्ट होत असतो. Therefore, bar magnet is called as a magnetic dipole, means it consists of two equal and opposite poles, okay, separated by some finite distance, twice L. Okay, then pole strength of this north pole is plus M and pole strength of this south pole is minus M. Okay, pole strength. Next definition. Then what is the pole strength? It is denoted by letter small m. The ability to interact the other magnetic materials is called as a pole strength and it is denoted by letter m. The ability to interact the other magnetic materials is called as a pole strength, and pole strength of north pole is plus m, pole strength of south pole is minus m. SI unit of pole strength is ampere meter. Okay, therefore one point is clear that magnetic monopole doesn't exist. Okay, it always exists in the pair. Okay, therefore it is called as a dipole. Okay, we can't distinguish where is a south pole and where is a north pole. Okay, therefore these two poles are called as a fictitious poles. Fictitious poles की ज्याचं तुम्ही अस्तित्व सांगू शकत नाही. Therefore it is called as a fictitious poles. Okay, this point is again important. Then the distance between two poles is called as a magnetic length. Magnetic length, which is denoted by the twice L. Okay, distance between the two poles is called as a magnetic length. This is the geometrical length. हे लक्षात घ्या. This is geometrical length and this is the magnetic length. Okay, you know the relations between geometrical length and the magnetic length. Okay, now next point is magnetic dipole moment. Magnetic dipole moment. It is denoted by capital M. What is capital M? Capital M is the vector quantity. It always directed from south pole to the north pole. This is the M vector, magnetic dipole moment. It is defined as, it is the product of pole strength means small m and the magnetic length means twice L. Therefore, capital M is equal to the twice M into L. Okay, this is the formula for magnetic dipole moment of a bar magnet. Okay, now you know that the current carrying circular loop acts as a magnet. Its two faces acts as a magnet. One face acts as a south pole and other face acts as a north pole. Okay, therefore current carrying circular loop acts as a bar magnet. Okay, therefore it has a two poles and its magnetic dipole moment is given by M is equal to the I into A, where I is the current flowing through that circular loop and A is the area of that loop. If this circular coil or loop has a number of turns, this equation becomes capital m is equal to n into I into a, where n is the number of turns of that circular loop. Okay, these two equations are very, very important. Okay, m is equal to the twice ml. This is the magnetic dipole moment of a bar magnet, and this is the magnetic dipole moment of a circular loop carrying current I. Okay, then what is the SI unit of magnetic dipole moment? SI unit of m is ampere meter, then Lenz unit, it is again meter, therefore it is ampere meter square. Here is I is measured in ampere, area is measured in meter square, therefore both these units are the same because quantity is the magnetic dipole moment. This quantity is very important as far as this chapter is considered. Now let us see the origin of magnetism. Building blocks of any material is atom. Atom consists of electrons, okay, which carries the charge. An electron is revolving around the nucleus, okay, in circular orbit. Therefore, magnetism originates from the spin and orbital motion of an electron, because this electron has a two motions, spin orbital motion, spin magnetic moment and orbital magnetic moment. Okay, therefore we have to consider that the magnetic moment of an electron revolving around the nucleus, we have to obtain the expression for magnetic moment. One point is clear that magnetism originates from the spin magnetic moment and orbital magnetic moment of an electron. Okay, let us see this diagram. In this diagram, electron is revolving around the nucleus in a circular orbit. Therefore, it has a orbital magnetic moment and spin magnetic moment. Okay, दोन्ही दाखवलेले आपण पहा. This is m is the orbital magnetic moment and s for the spin magnetic moment. Okay, then what is the r? R is the radius of the orbit. की ज्या ऑर्बिटमधनं इलेक्ट्रॉन्स मूव्ह होणार आहे त्याची जी काही रेडियस आहे ती काय आहे, स्मॉल r आहे. Then an electron revolving in a circular orbit, it acts as, or it is equivalent to the current loop. This is the direction of current and this is the revolving directions of a electron. Okay, जो काही इलेक्ट्रॉन्स हा सर्क्युलर मोशनमध्ये फिरत आहेत किंवा ऑर्बिटल मोशनमध्ये फिरत आहात की त्यावेळेस त्याला काय असणार आहे की ऑर्बिटल मॅग्नेटिक मोमेंट असणार आहे अँड ॲज वेल ॲज इट हॅज ए स्पिन मॅग्नेटिक मोमेंट. Okay, and it is equivalent to the an electron which is revolving around the nucleus, which is equivalent to the current loop, and therefore the magnetic moment of a current loop is given by the equation m orbital is equal to the I into a. Say equation number 1. Just आपण मॅग्नेटिक मोमेंट डायपोल मोमेंटचं इक्वेशन्स पाहिलेले तेच आपण लिहिलेले फक्त ऑर्बिटल मॅग्नेटिक मोमेंट. Okay, this is I into a, where I is the current flowing through the loop and a is the area of the loop. Now an electron is moving with a constant speed v in a circular orbit of radius r. Therefore, what is the orbital velocity? V is equal to the, of course, 2 pi r upon t, distance upon time is the velocity. Therefore, v is equal to the 2 pi r upon t. Now, what is the I? I is equal to the E upon t. Okay. Therefore, I is equal to the E upon t चे इक्वेशन्स इथे काय मिळाले तुम्हाला पहा, t is equal to the 2 pi r upon v. Okay. Therefore, I is equal to the E upon t is 2 pi r upon v. Okay. Therefore, I is equal to the EV upon 2 pi. This is the equation of I, current flowing through the loop. Okay. Then put this value in equation number 1. Therefore, we get m orbital is equal to the S I ची value EV upon 2 pi r into A as it is. Therefore, m orbital is equal to the EV upon 2 pi r into pi r square. Therefore, m orbital is equal to the 1 r get cancel with this 1 r, pi get cancel with this pi. Therefore, it get EVR upon 2. This is the equation of magnetic, of course, orbital magnetic moment of an electron revolving around the nucleus. It is very important. Therefore, for this electron, what is the orbital angular momentum? Orbital angular momentum is the L. L is equal to the m e, mass of electron, into v into r. Already you are familiar with the angular momentum. Angular momentum for this electron is L is equal to the m e into v into r. Okay, where r is the radius of the orbit, v is the velocity, and m is the mass of electron here. Okay, this is the equation of L. Okay, say this is equation number 2. This equation 2 can be written in this form: m orbital is equal to the series E upon m e upon m e into m e VR upon 2. See this, E upon ME into ME into V into R upon 2. Okay. Then from this equation, आता ह्या इक्वेशनला आपण काय केलेलं आहे, फक्त एमीनी डिवाइड पण केलं आणि मल्टिप्लाय पण केलं, म्हणजे ह्या इक्वेशन मध्ये काही परिणाम झाला नाही. ओके. देअरफॉर वी कॅन से दॅट m orbital is equal to the S. What we get? What is this? ME into VR. ME into VR is the S. It is L. Therefore, we get here L upon twice ME. Okay. This is ME into VR is the L. Okay. And this is the twice ME. And here is the E. Okay. Therefore, we get m orbital is equal to the E into L upon twice ME. Okay. This is the equation of magnetic moment of electron in terms of the angular momentum L. Okay. Because ME into VR is the L, E as it is, and it twice ME. Okay. In vector form, this equation can be written as m vector orbital is equal to the minus E into L vector upon twice ME. This is the mass of electron. Okay. Then negative sign indicates that this m orbital magnetic moment and the L vectors means angular momentum are in opposite sign. Okay. Then ratio of E upon twice ME is called gyromagnetic ratio. Gyromagnetic ratio. Okay. If you put E is equal to the 1.6 into 10 raised to minus 19 coulomb into 2 into mass of electron is 9.1 into 10 raised to minus 31. Then this becomes 0.08 into 10 raised to, yes, this is minus 12 plus 12 will, okay. Therefore, it becomes 8.8 into 10 raised to 10 unit of charge is coulomb. Mass of electrons is kg, coulomb per kg, and this is the value of gyromagnetic ratio. It is the constant and it becomes 8.8 into 10 raised to 10 coulomb per kg. You can find out this. The ratio of E upon twice Me is called as a gyromagnetic ratio. Okay. Then for electrons, the angular momentum L is equal to the nh upon 2 pi according to the Bohr second postulate. L ची व्हॅल्यू काय असते nh upon 2 pi where n is the orbital number. Okay, h is the Planck's constant and 2 pi is the constant. Okay, ती जर व्हॅल्यू आपण L ची इथं पुट अप केली या व्हॅल्यू मध्ये then you get the m orbital as L is equal to the nh upon 2 pi, then m orbital is equal to the E nh upon 4 pi m into E. For first orbit, this m orbit is equal to the Eh upon 4 pi m in E. And this orbit is called as a Bohr magneton. The quantity Eh upon 4 pi me is called as a Bohr magneton. हिला इथं नाव काय दिलेले आहे तर it is called as a Bohr magneton. All this is important point. Expression for m orbital is equal to the EVR upon 2. Okay, and equations between or relations between the orbital magnetic momentum and angular momentum. Okay, this is the value of magnetic moment of an electron around a